Okay guys, quick review here. We're on section 8.1, inverse and joint variation. We've already done direct variation, so we're going to review that real quickly. If you look back in your notes, first we started talking about a constant of variation. We denote that as x. We've got our equation here, y equals ax. I like that equation because it's set equal to y, and we can graph that. So as one quantity increases, another quantity increases. I'm going to plug in also. As one quantity increases, another quantity also increases. We see that here with the equation we've got. We'll make an xy table, plug in some simple values for x, and we'll get these values back. Okay. So we can see here that as x increases, y increases. That's the idea of a direct variation. One goes up, the other goes up. Okay, now for new stuff, inverse variation. Now the book uses this. Let me do this just to make sure that's not a negative sign there. I should get that out of the notes. So an inverse variation can take the form x times y equals a. A again is our constant of variation. I prefer a different form. We can look at it like this. If we divide both sides by x, the point here, of course, being to solve for y, we get y equals a over x. Now, I like this form better. Your book likes to use this one. We can work with either. Okay, so what I'm going to do here is divide both sides here by x. We'll make another xy table. We'll use those same numbers. And again, it doesn't matter what you plug in for x. These just make it nice and easy. So y equals 12 over x. Okay, so 12 over 1, of course, is 12. 12 over 2 is going to be 6. 12 over 3 will give us 4. And 12 over 4 will give us 3. Okay, so we see here that as our x goes up, our y is going down with this equation. That's the idea of an inverse variation, right? X goes up, y goes down. If we want to graph that, we certainly can. We'll start with 1, 12. I'm going to say that's about there. 2, 6, 3, 4, and 4, 3. Now, what we ought to notice here with this particular graph is that it's not a straight line. We're going to have some kind of curve in it like that. We're going to be talking about asymptotes, things like that, with these types of equations. But we'll get into that later. Okay, let's talk about inverse variation a little more. Y equals 7, x equals 4. We're going to talk about an equation that relates x and y inversely, right? Inversely. And then we're going to find y when x equals -2. Okay, so what we're going to start out with is our inverse variation equation. Now we can either go x, y equals a, or we can use my preferred method, y equals a over x. Now it really doesn't matter. This procedure will work the same with both, so we'll go ahead and do it with both to start with. Okay, so let's come over here. First it tells us that x equals 4, y equals 7, so we'll plug those in. We've got 4 times 7 equals 8 equals a. Okay, we can do that. 4 times 7, of course, is 28. That equals a. If we do the same thing over here, we've got 7 equals a over 4. To solve that for a, we're going to multiply it by 4. We again get 28 equals a. Okay, so we found a. Now we can come back up here to the second part of the problem, find y when x equals -2. Well, we found a. We're going to try and find y when x equals -2. So let's use this one. You can certainly use the other one if you like, but I like this guy. So we don't know y. We do know a. We found a down here is 28 over a -2. Okay, from right here. Y equals 28 over a -2. Well, that's pretty simple. Y, we're going to reduce that, sorry. Y equals a -14. Okay. So we can solve for an a, for our constant of variation, given two variables, our x and y, and then we can use that to then solve in any instance when we know what our constant of variation is. So if we don't know what our constant of variation is, we're going to need an x and y to find it. And if we do know what our constant of variation is, then we can use that to find x or y. Okay, let's move on. All right, direct, inverse, or neither. Let's take a look at these equations and try to decide whether they are direct variations, inverse variations, or neither. Remember, our direct variation equation is going to look something like that, and our inverse variation, the equation, is going to look either something like, or in my preferred case, something like that. Okay, so let's take a look over here. Y equals 2x. Well, that almost exactly looks like our first direct inverse equation, so we're going to say that that is a direct. Our constant of variation there, of course, will be 2. Okay, our second one in the list is 5/3 equals x. Well, that really just tells us what x equals. So we're really not talking about any kind of a variation because we don't have a y. We have one variable. So I'm going to say this is neither. And we'll take a look at our third one. Again, that one looks almost exactly like our first direct variation equation. We've got it flipped around backwards, but that doesn't make any difference. Our constant of variation will be 3, of course, so this is direct. Okay, x plus y equals 2. Well, we haven't really dealt with anything yet where we're adding our x's and y's. So in this particular case, we don't have any multiplicity. We're not multiplying anything together, we're just adding. So we haven't done anything with that yet. We'll say that's neither. Okay. And we move down here to our next one. We have 9y equals x. Well, let's take a look here. Let's solve that guy for y and see where we come out. We'll divide by 9. We have y equals x over 9. Well, y equals x over 9. So that looks a little bit like one of our inverse variations, except that x is in the numerator rather than the denominator. So let's try and write this in another way. We'll go y equals 1/9 x. Now that's, of course, legal, right? So now I think we're starting to look a little bit more like our direct variation, this being our constant of variation. So this guy will be direct. Okay. Now, over on the other side, we've got xy equals 0.75. Well, that, as it stands now, looks a little bit like your book definition there for an inverse. We've got an x and a y on the same side, and we've got a constant on the other. It happens to be a decimal, but that's fine. That's not a big deal. So this guy on the bottom, that's going to be inverse. Okay. So we've identified some variation here with our given equations. Now let's talk about joint variation. Z varies jointly with x and y, is how we'd say that. We, of course, still have our constant of variation, A. That's always going to stay the same. If we take a look, we'll excuse that. Let's take a look in our book. Page 551 gives us, page 553 gives us a definition for joint variation. It says joint variation occurs when a quantity varies directly with the product of two or more other quantities. Okay, so we've got now a third quantity. We've got x, y, and now z that we're going to use as our variables. We're going to say that one of these variables, z, varies jointly with x and y. Now this will be a product of x and y. As we see here, we've got x times y. So z varies jointly with x and y, or with the product of x and y. Okay, so our directions here say write an equation, then find z when x equals 2 and y equals 6. Okay, well, if we remember from our last slide, first thing we had to do, excuse me, we'll back up one more. First thing we had to do was to nail down our constant of variation. We had to figure out what that was, what A was going to be. Well, if we go back to our joint variation now, we've got Z, X, and Y, and we're going to try and find our constant of variation. I think we can handle that. All right, Z, we're going to pull this equation down here, and we're going to substitute in what we've got here. So, negative 75 for Z equals A times XY. X is 3, and Y is a negative 5. Okay. So let's start on the right side of the equation here. 3 times a negative 5 will give us A times a negative 15. Negative 75. Now if we're going to take a negative 75 and we're going to divide that by a negative 15, we're going to get, that's right, we'll get a negative 5, excuse me, a positive 5. All right? Okay, we'll get a positive 5 for A. So now we've got our A. Now we can write an equation and find Z when X equals 2 and Y equals 6. Remember, we're still using this joint variation equation. Let's try it out. We're going to find Z. So we don't know what Z is. We do know what A is. A is 5. X is going to be 2. And Y is going to be 6. Okay. So we can do this in any way we like. Let's take 2 times 6 is 12. 5 times 12 is 60. Z equals 60.